Hey guys, our third number theory proof here, and this is pretty cool because what we're going to do is show that a number of this form where the quantity inside the parentheses is prime will have to always be what's called a perfect number. And so an example is 8128, which is the only perfect number between 1,000 and 10,000. As you can see, we can write it in the desired form. Now, the smallest perfect number is 6, and the way we define a perfect number is as a number that's equal to the sum of its proper divisors. So 1 plus 2 plus 3. So the proper divisors do not include the number itself. But here, what we're going to do to prove this statement true is this, which is we define sigma of n. And sigma of n is that, and all it means is the sum of the divisors of n. So in the case of 6, sigma of 6 would have been equal to 1 plus 2 plus 3 plus 6. This is for sigma of 6. And so if we want a perfect number, it seems like what we should do is define sigma of n to equal to n, because sigma of 6 is 12. And we know that 6 is a perfect number. And so, yeah, and it makes sense based on the definition of sigma that we require sigma of n be equal to 2n, because sigma of n adds up all of the divisors of n, and therefore it adds all of the proper divisors of n, which we require to be equal to n if n is a perfect number. And then we have that n, we added the end, so in total, when we're looking at sigma of n, we require that it be equal to 2n. Where again, one of the n's is the sum of the proper divisors and the other n is n itself. Okay, cool. So, the way we're going to show that this number here is a perfect number is by using sigma of n. In particular, we're going to need to show that sigma of n is equal to 2n. Now, sigma of n is what's called a weakly multiplicative function, and that's because sigma of a times b is equal to sigma of a times sigma of b, so long as a and b are relatively prime. That is, so long as the GCD of a and b is equal to 1. Yeah? Okay, cool. So using this, we see that sigma of n, our number n in yellow here, is equal to sigma of 2 to the, I don't like that sigma. Sigma of 2 to the q minus 1 times sigma of, don't like that sigma either, sorry guys. Sigma of 2 to the q minus 1, right? Okay, cool. Now, what is this? What is sigma of 2 to the q minus 1? Well, it's a sum of its divisors, right? By definition, right? But what are the divisors of 2 to the q minus 1? Well, we can list them. One of them is 2 to the 0, or 1. Another is 2 to the first. A third is 2 to the second, and so on. And so dot. And then finally, we have to end on 2 to the q minus 1 itself, right? Okay, these are the divisors of 2 to the q minus 1. And so sigma of 2 to the q minus 1 is just a sum of them. So we just put a plus sign in between, right? Okay, cool. But then they form a geometric series. And so by the geometric series sum formula, we can write that their sum is equal to 2 to the q minus 1 divided by 2 minus 1. But why should we bother in dividing by 2 minus 1? That's just dividing by 1, so there. So we see that sigma of 2 to the q minus 1 is equal to 2 to the q minus 1. So we say that sigma of n so far looks like 2 to the q minus 1. And then we have sigma of 2 to the q minus 1. So what about 2 to the q minus 1? What is sigma of it? Well, remember, we said from the start that this guy here, we require it to be a prime, and it's called a Mersenne prime. Since it's a prime, since 2 to the q minus 1 by definition is a prime, then its divisors are only 1 and itself. And the sum of them, sorry, I don't know why I said, I thought I wrote that one right there as an exponent. That's why the O, in case you cared. But anyway, the sum of them is 2 to the q. So we see that sigma of 2 to the q minus 1 is just 2 to the q. So we go, this is 2 to the q. Okay, cool. And then we can manipulate this very last thing we wrote and write the following, which is that sigma of n is equal to 2 to the q times 2 to the q minus 1. All I did is commutative property of multiplication. And then I can rewrite this as 2 to the q, I can rewrite it as 2 times 2 to the q, I was too eager to finish, 2 to the q minus 1 times 2 to the q minus 1. Obviously, this here is that, and these two together make that. But wait, that's why I was eager. Look at this. That there is n itself, ain't it? So we've got 2n. That is, sigma of n is equal to 2n. And that's what we require in order for n to be a perfect number, yeah? Okay, cool. I hope you enjoyed this, and keep watching. Take care.